Hello everyone. Today we're going to work on a mechanical translational system. I'll go with this example. A simple car suspension system model. A car is moving on a road with irregularities. Alright, I'll add the components. A mass and a spring. I mean a translational spring, followed by a damper. Let's connect them. And I'll specify the parameters. The road input is a displacement. However, there is only a velocity source, so we have to use it. And then we have to measure the position of the mass. Add a motion sensor. This sensor captures the displacement of the mass and provides an output that we can use for analysis. Alright, let's add the road profile. The vehicle moves through a 1 meter wavelength at a speed of 10 meters per second. So it would be 10 hertz. It looks like it's done, but don't forget that the source is a velocity source. Therefore, we should transform it into a velocity. I'll do it by taking a derivative, like this. Alright, let's see. As you can see, the result is strange. The input is a sine wave that oscillates around equilibrium, but the output has a DC offset of 2 millimeters. I'll compare it with the input for clarity. As you can see, the result is bad. The time step is also bad. Let's adjust the time step. Well, this might work. Alright. The response seems to oscillate around 0. So I think it's adequate. Now, for the ramp road profile, I'll use ramp functions and combine them like this. Add a sum block. Gain block. Change the slope to -1 and change the time interval based on its speed, 0.1 seconds. To switch the input, I'll introduce a manual switch block, which allows you to change the case without having to delete and add blocks. You can change a case by double-clicking on this block, like this. Now, let's see the results for this case. Okay, it behaves as it should. Let's move on to compare it to the mathematical model. It's CS plus K. Okay, now go ahead. For the ramp case, the results matched. And for the sine wave case, you'll see the inaccuracies in the results. The imperfection occurs because the transfer function obtains the input directly from the road profile, while the Simscape model has to convert it with the derivative. It can be fixed by increasing the sampling points or narrowing the time step. Let's see the results again. The results are still not perfect, but they look better. The accuracy of the differentiation depends on the time step, which means that a larger time step can introduce numerical errors and reduce the precision of the velocity computation, leading to discrepancies in the response. I hope you found this helpful. If you have any questions or want to see a specific topic, let me know in the comments. Thanks for watching, and I'll see you in the next video.